In this video, we're going to look at some different models to help us understand relations. We're going to describe some different models and we're going to illustrate them with some examples. We're going to see how different models give us different understandings of a given relation. And then we're going to see how some models lead to different types of relations. So here is a model that applies to any relation, and I call it the social media model. So the relation R can be thought of as expressing a relationship on social media. So I'm thinking, for example, something like Instagram or Twitter. You say that A is related to B, ARB means that A follows B. So you can have A and B be like people in a following relationship where A follows B. Note that it is not necessarily true if A does follow B that B follows A. It's not necessarily a symmetric relationship. So recall the less than or equal to relation on real numbers. Here, A is related to B means A is less than or equal to B. Since 2 is related to 5, we could think of 2 follows 5. And in fact, all smaller numbers follow all larger numbers, but not the way around. Larger numbers do not follow smaller numbers. So we have a visual model for relations as well. This is called the directed graph model. Suppose we have a relation R between sets A and B. If A is related to B, in other words, ARB, we express this as A pointing to B with an arrow between A and B. So here's an example of a relation as expressed using ordered pairs. So 1 is related to 5, 2 related to 8, 3 to 7, 1 to 2, and 3 to 5. If we want to express this as a directed graph, here's one way we can do it. So if we take that first ordered pair, 1, 5, that means 1 is pointing at 5. So we have 1 and 5 with an arrow originating at 1 and ending at 5. If we do the same thing with 2 and 8, 2 is related to 8, we have an arrow between 2 and 8. 3 is related to 7. The arrows don't have to go left to right. They can go up or down. So 3 is on top, 7 is on the bottom, and 3 is pointing to 7. Now the next one is 1 and 2, and these are actually already numbers that we have. So we can use the numbers where they are. And the only thing is we have now an arrow between 1 and 2. And same between 3 and 5. 3 and 5 are already existing within this directed graph, but we just now have 3 pointing to 5. And then this directed graph, this sequence, all these numbers and arrows pointing between them tell us what the relation is for R. Now, the models before this were models that could be used for literally any relation. Here's a model that only applies to certain relations, and I call it the family model for equivalence relations. So an equivalence relation can be thought of as a family relation. In other words, when I say A is related to B or ARB, I mean related as in family relations. So A is in the same family as B. Now, family relations behave a little bit differently than relations in general, in particular some of the relations that we were looking at before this model. For instance, every person is in the same family as themselves. So that means in terms of our relation language, that means A is related to A for all people A, ARA. So if A is in the same family as B, then it is also true that B is in the same family as A. We got this symmetric relationship, right? So if A is related to B, then B is related to A. And also, if A is in the same family as B, and if B is in the same family as C, that also implies that A and C are in the same family. Which means, if we're using the language of our relations, if A are B and if B are C, then A are C. So we get 3 additional properties of relationships that are like the family model. And so we're going to go ahead and name these properties that are inspired by the family relation. So let A be a set, and let R be a relation on the set A. We say that R is a reflexive relation if A is related to A for all A in big A. We say that R is symmetric if whenever A is related to B, then it automatically follows that B is related to A. And we say that R is transitive if whenever A is related to B and B is related to C, then it follows that A is related to C. Now again, not all relations have these properties, so that means that not all relations are going to have them. So I'm going to give you a visual representation of these properties, and the visual representation is going to be using the directed graph model. And so you might notice that each of these properties, except maybe the first one, are if-then statements. So all of them have things that you are assuming and then things that you can conclude. So I'm going to use different types of arrows to indicate each of those things. So the solid arrows are going to represent the things that we're assuming in the property. And then the dashed arrows are going to represent the conclusions that we can make based on those assumptions. Now the reflexive property kind of doesn't have anything that you're assuming, although when we start proving things are reflexive, you'll see that you kind of do have some assumptions that you have. But basically, if you have any element A, reflexive means that it's going to point at itself. So really, any element that you have in A, it has a dashed arrow going to itself. It's automatically true that A has an arrow pointing to itself and from itself. So symmetric, here we're assuming that one element is related to another. So let's say here we're assuming that A is related to B, and if that is true, and we have the symmetric property, then we can conclude that B is related to A. And finally, for the transitive property, we start by assuming A is related to B, and we're assuming that B is related to C, and from those two things we can conclude then that A is related to C. Now, if we put all these three properties together, we get something that's called an equivalence relation. So let A be a set and let R be a relation on A. Then R is called an equivalence relation if it satisfies all three of those properties. In other words, it satisfies the reflexive property, it satisfies the symmetric property, and it satisfies the transitive property. So now that we've got these definitions and some models for understanding relations, go ahead and try working on the in-class activities. The PDF file is called More Relations.